No, thanks, Kaylin. Thanks for having me. So my talk is not going to be very technical today, right? It's going to be giving you a lot about industry perspective of what is happening in this physical AI, or in other words, embodied AI, where you can have both agents in the physical world, but also in the virtual world as well. So, Microsoft Research, people ask us like, what is Microsoft Research doing in this? Why is Microsoft even in robotics? What are you guys doing? I always say we kind of like it that way, right? We like those questions. We like to stay under the radar, and we're working on fundamental research to unlock the the paradigms for autonomous intelligence systems, robotics, and gaming intelligence as well. And how do these three nexuses converge? So imagine a world where robots just don't execute command, but they are actually navigating the complex reality of unstructured environments, right? So some of the researchers that I'm going to share from my team is you're going to see some familiar names from UMD as well. Okay, so if we look at what embodied AI is from our standpoint, or even from industry, when we work with customers in doing research collaborations, right? It's not just the physical world, but it's also the virtual world where agents do have to see, act, and think. Or in the classical robotic stack, you may say plan, perceive, act, or take action or control. So from an embodied AI standpoint, it's the agents both in the physical and the virtual world. But before we dive into that, and those three intersecting circles, and how they were the brain, body, and the, I guess I could call it the neural network or our nervous system working together, it is important to go through the history of this, right? So this timeline showcases the history of artificial intelligence. AI has had its winters as well. But at the same time, overlay that with robotics. Robotics has its glory days, and it's also had its own winters as well. And then all that stuff that's happening in the last 4 years, right? I thought 2025 was the year of the agents, but being continuously proven wrong about how much development's been happening from industry standpoint, from academia standpoint, from institutes standpoint, also in embodied systems in the physical world. So the key history lesson that has taught us over time that yes, we will have summers, we'll have winters, but this time it might be different because these two technologies are starting to converge, from artificial intelligence to being the accelerator for the field of classical robotics. I want to talk a little bit about world models a bit. So just like how each one of us right now are having an entire mental map of the world around us, is also the way Microsoft Research is actually doing the fundamental theoretical research in leveraging the transformer architecture to develop world models. And I'm going to share some examples with you. Of course, we as humans, I know there were some talks about the spatial mapping and processing through our visual cortex. Yeah, we receive information through the numbers out there, right? Through these neurons and sense the world, we plan accordingly, and then we take action as well. So navigating through this complex environment, through our hippocampus, creating the spatial maps, and integrating all of this into a coherent understanding of the world. It's pretty fascinating of our evolution over time. So embodied AI at Microsoft and Microsoft Research, I should also indexing on it, is broken out into three verticals for research purposes. So you have autonomous intelligence systems, we call it like the narrow body systems that are trained to execute certain tasks. we have the classical field of robotics, whether we're doing dexterous manipulation, bimanual coordination, and then gaming. And how are we leveraging world models from games to train robots in the real world as well? Want to talk a little bit about this has been a pretty exciting and fascinating development over the past few years. Vision language action models, VLAs, and the architecture of leveraging a deep neural network through a transformer architecture with text tokens, prediction tokens, and then also visual odometry. Going and talking a little bit more about how do you do prediction in the real world when it's super unstructured. I am not sure what somebody else in the back is going to do, right? But through my conversations, can I predict some actions to take in the physical world as well? So we are leveraging the transformer architecture and then also doing the latent space grounding around the transformer architectures for robots to take, and I'm going to share some examples and videos to take action in the physical world itself. And then we always have this debate, is it pixels or is it newtons, right? Is it a measure of force or is it a measure of diffusion models as well? So there's always a hard debate between my research teams from hardware standpoint, or is it the brain overall? You may recognize this model, Magma. So it was a foundation model for multimodal agents, right? So agents, think about it this way, an agent that can be in the virtual world, but at the same time can actually translate actions in the physical world. There's a author on the paper from University of Maryland as well. So this was a release, and now the model has been released. It's open sourced. And we're continuing to fine tune it with our industry partners on how does this impact industry. One of the companies that we collaborate with, it's in home robotics, and they will talk about agents that can actually help you do spreadsheets in a couple of years, but at the same time, same model can help your home robot clean your house in a few years. So this is talking about, you can put some GPS, like these dots that you see, think about them as like GPS locations or standpoints of where they are to actually take the action in the latent state that they operate. So it's an agentic AI workflow, both in the physical and the real world. The other one is Trace VLA, again, also a collaboration with the University of Maryland and Microsoft Research, talking about multi-point tracking and how we take those several points of tracking to do proprioception, and then also grounding the object with the robot itself, right? So if you change the scene behind it, or if you displace the object, it is still grounded within what the task between the machine and the object is. Of course, trained on the Open VLA, which is open source, fine-tuned with multi-point tracking, and we did publish that model as well recently. Okay. Oh, there we go. Okay, so on the left-hand side, what you're seeing is one of our researchers actually doing learning from observation, learning from demonstration with some RL policies, and then robots following either on the floor below him or across country, across the ocean there. So that's one of the ways learning from observation is one of the methods that we're teaching. The other one is also the world modeling piece that I talked about earlier, is how are we leveraging games? So Bleeding Edge, we've released a paper called WHAM, World Human Action Model. How are we taking gaming, bringing down the frequency of gamings with a good physics engine and a reasoning model to work with home robotics as well. So these are just some examples that are coming out of Microsoft Research with our collaboration with academic partners. Robots learn through different ways and different technologies. That's still a debate within academia and research. But wanted to share just some causal reasoning piece of what our team is working on. If you know this game, it's called a bomb diffusing game. It's actually a virtual game. But we have actually taken this Aloha mobile kit, trained it, and given it some causal reasoning, just as an example that I could share. So if you could hear that, one of our teammates said, can you turn the knob to the number of arms you have, right? So having that causal reasoning small model that's coming out of our India team, we integrated that into a VLA that we had just to kind of train the robots to take action in the physical space as well and to reason. Oh, as part of the reason is also the memory cortex in humans. So as LLMs are starting to get memory more and more, we're also giving video tokenizers memory as well to do causal reasoning. Another model that we have released in a paper in cross collaboration coming out of our Asia team in Tokyo and Beijing and Shanghai is grasping. Dexterous manipulation, and I've been talking to folks around, it is still the holy grail for robotics, right? Hasn't cracked it. Just within our Acela corridor from DC to Boston, there's 9 universities that are working on it, 34 universities globally, working on dexterous and precision manipulation. And then Unigrass Transformer, same, based on a transformer architecture about prediction tokens, predicting video tokenizers to take action, is another multimodal model has been released for dexterous manipulation as well. And the purpose for Microsoft Research is to release this in a lab-based environment, but then we also partner with our customers, right, to go into their environments as well. And one of the projects that I'm going to share here is going to be a reflective of an environment that it is. This is an RL policy that's been trained on quadratics. This is basically how Legos get stacked based on geometry from sim to real. And applying, this is without tactile or haptics, is just more based on passive and active force. Shadow arm, I was joking with somebody yesterday. Shadow arms are usually, you have to buy them 3. One is always in repair, one is in shipping, and one you can actually work with. But yeah, they're very brittle and delicate. But now there are arms that are coming out that are, you can even 3D print for $1,300. I just saw that from NYU the other day as well. Oh, even better. I love it. So what does this mean, right? Yes, how do we prevent another winter for robotics or an AI winter, et cetera? So I know there's a lot of comments about robotics will have a ChatGPT moment. Maybe, I don't know. I don't believe so. ChatGPT moment is 100 million users in 1 week, right? That's what people reflect to ChatGPT. Our intuition is going to be, it's going to be an ecosystem that comes together, right? Think about it like the Windows or Android even, that enables operators. So think about operators as folks that are going to be deploying these robots in there. They're not building it, they're deploying them. So let's give an example. Walmart, right? Caterpillars of the world, et cetera. Then there are the builders, right? There are hardware builders, there are software builders. KUKA, ABB, humanoid builders, figure agility, et cetera. Research accelerators. Academia is so important in this moment that we're living in for robotics or even for embodied AI. Because guess what? Who has the most data? That's pre-trained today, right? If you're living through the data story, it is still very relevant. Not many people have data to train models. Yes, there are new novel techniques that are coming out, but academic labs, research, and even the research labs within institutions, whether it's Google, Microsoft, Meta, others as well. And then for AI to work in the physical world, you will need some standards and guidance and responsible deployment, right? So that is the ecosystem that MSR and Microsoft Research is trying to build a platform to have an end-to-end story overall. So one of the compelling environments that we're working on, if you could kind of guess what this environment is, please feel free to just shout it out. But folks think it's very structured. It is not structured environment. Lighting is different. There's stuff in the aisles. There is a joke between the technicians that work in this environment. If you don't have a scar on your hand, you have never worked in a data center, right? It's not a safe environment either. It is super loud. So Dr. Gao, I'd love to kind of hear a little bit more about your acoustics, right? And how can we do precision acoustics in a 110 decibel loud environment, right? When you have GPUs and CPUs running and hard drives running at full speed. So highly dexterous precision manipulation, large, heavy trays that you have. So it's a grand challenge for folks to kind of work in this environment. And that's some of the areas that we are collaborating with academia. We have the setups that, hey, if you want to go try some of your models out, come join us, right, in this ecosystem. Talking a little bit about precision manipulation, right? This is one of our teams in the research teams in the UK. Same thing, similar type environment. Trying to get through those cables and having those latch and feeling that vibration is something different, right? In this high density environment. But if you solve that, it just opens up a whole ecosystem of potential opportunities as well. So we're also looking at how do we translate the technology and the research into other applicable problems as well. Yeah. And with that being said, these are some of the publications. Like I said, we're a little bit conservative. So yes, we do publish everything on our website and the papers that we have written. These are just coming out between last year and this year, and some of the ones that I shared overall. So overall, it is going to be an ecosystem that kind of drives this moving forward. And with that being said, thanks for the opportunity. I look forward to collaborating and hearing more about the technology and how we can apply to the real world with industry partners as well. Yeah.
Thank you. Very nice talk. I have a following question. Okay, so in many of the manipulation tasks you described, depending on the flexibility of the fingers and the construction and so on and so forth, I don't know if you're familiar at all with the German Institute for Robotics that is near Munich, where I work also, okay? So they have this two-arm manipulator, which does extremely detailed tasking for both the arm location and the fingers as a three-dimensional motion planning problem, okay? Right? So it's an overkill, if you like, but you can give me a precise location of the sphere of my extent of my arm, right? Or in the extent of each figure, and I can give you a precise path mathematically. No machine learning, nothing, okay? Yeah. So and this involves difficult mathematics on exponentially groups and all stuff, things that we here in Maryland we understand very well, okay? So the question is, if I have this kind of mathematical prescription of high complexity, fine, but I can compute by solving the problem, why I cannot try to put it together with some adjustments from machine learning and get much better results? Is that in your mind, is that something? Because I've talked to a lot of people and including myself, we believe this is the direction to go now, not just go data-driven, but try to integrate what's called domain knowledge, what I described, and whatever you can do there with the data-driven method, especially robotics. What's your reaction to that comment again?
Yeah, that's a really great point, John. So there are certain things that AI or machine learning will help, but then there are certain problems that classical field of model predictive control, that's okay to do as well, right? And that's what the second video that I showed you about precision manipulation, there is no AI or ML. It's MPC, classical MPC, just to get me to the point that I need to, and then I can figure it out, right? So yes, there is definitely an opportunity. I think it's a hybrid model. But yeah, I would love to learn a little bit more about.
And then a couple of years ago, I was listening to a talk by the CEO of Boston Dynamics.
Yeah.
Right. So he comes and says, you know, we started, and I'm not exactly quoting him, but he says we started as a detailed modeling and simulation company. That's how we built the company. And all the stuff that the Atlas and others do is they have very little machine learning. This is all by detailed modeling and control and things like that. And
Yep.
And that's what got me started along this direction. Hey, you know, whatever I know, I shouldn't throw it away. Maybe I can add to it machine learning. Anyway.
No, and to that point, really quick, I'll just comment. So at CVPR this year, we're hosting the Embodied AI workshop, and we're trying to have these VLA models compete with each other, right? Because even VLA models are very brittle today. I think the best performing one that we know of is Alibaba's Qwen 2, which is still at, I think, 72% precision and accuracy, right? But yeah, they're still not performing it. Yeah. Yes. You had a question?
Yeah, thanks for the great talk. My question, and forgive me if I'm naive, but it's kind of based off where does AGI come into this field of robotics that we talked about, embodied AI, and what do you think, what would be the general timeline of this kind of scenario that we are talking about right now?
Yeah, AGI, thanks for the question. The way we're saying AGI, it's nothing about super intelligence or getting the intelligence to the next level. Is it making progress in the real world? Is it changing a GDP? Is it lifting people out of poverty, right? To get to that artificial general intelligence. So if it's really lifting up, I think there's numbers out there from Morgan Stanley, from ARK Investments, that it's going to drive $13 trillion of GDP growth, right? US GDP is at 100 trillion right now. But in order to do that, AI needs to come into the physical world and make meaningful impact and uplift the population, right? So that's how we are actually measuring GDP, or a path towards AGI. Is it driving some major economic impact rather than just pure intelligence that's residing in the virtual world versus the physical world? Timeline is probably, your timeline is as best as mine based on how much progress we've been making in the past few years. But still, I would love to see that real world utility to drive towards that. Thanks. Yes.
Hi, great talk. Thanks so much. So thinking forward, you were mentioning a lot of collaborations with academia. What are those areas that you find and that Microsoft is most interested in collaborating with academia in the near future?
Yeah, no, thank you for that question. Definitely one of the areas that we want to be laser focused and indexed on is dexterous manipulation or bimanual coordination. Because we do believe more than mobility, and we have our roadmap for mobility, manipulation, and human-robot collaboration, which is probably an output of those two, is how we want to collaborate and get industry and academia to come together to make meaningful progress, right? Like the research that our team had done, 34 universities around the world have been working on this, right? And 9 just on our eastern seaboard. So how can we collaborate together and drive meaningful progress? We don't need to solve it. We just have to have that meaningful inflection point that makes people pause and say, oh, I can actually leverage this and unlock value. So there's different ways we have collaborated. We have just done regular research collaborations. We have actually sponsored students in MSR as well, even at our Nerd Lab in Boston. And also through just academic exchanges and forming a consortium to get data in one place so folks can start using that data that's annotated, structured, and representative as well. We would love agriculture. Yep.
I come from Greece, so there they take the stick and they hit it and they put the seed down and collect the olives. Okay, but now they try to figure out if there's a robotic way to do that.
Yeah.
And why that's an important area, because it's usually tedious. You work in difficult environments. And I'm trying to get into that area, but I have a major concern. I want to see your view because I like you mentioned economic data. Okay, what I'm concerned is because we try to work with John Deere and all that stuff with satellite communications to all the robots. If we roboticize this market, is this going to wipe out the small farms? Because I don't want to do that. I want to give a help to the small farmer, because in the old days we had a company, not myself, but in the area that I was working on, that they will go either with planes or satellites. And if you're a farmer, you go in the morning and get as an internet service a disease analysis of your plants. And they will say, in this area, I suspect you have this kind of problem, go do something, right?
Yep.
And this was actually a commercial company that was offering this as an internet service. And it was very helpful to small farmers, because now for very little expense, they were getting this information, right?
Yeah.
So back to my question, if we roboticize agriculture of all kinds, is that going to be good for the small farmers or the big farmers? Because I think we should protect the small farmers.
Yeah, so the way I would address the agriculture piece, and we have a couple of projects. There's a project called Project Gecko for farming in India and Africa, how we're enabling those small farmers. We're looking at the holistic view, right? So we have a weather prediction model. So that gives farmers a prediction token in a way to say, hey, if I can actually help through Copilot, integrate this weather prediction model first, to say, when was my harvest going to go bad? How does this season look, et cetera, based on the wind patterns, et cetera, and so on. Robotics, it's still in the hackathon phase, I'll put it that way, right? In farming. I was part of a judging panel in our global hackathon. They were doing strawberry picking with robotics, right? I still feel that it's still got a while to go. But yeah, I mean, it's all about enabling the communities together as well. Yeah, just the strawberry, not the whole thing. Yep. Yes.
Yeah, thank you for the talk. Yeah, when it comes to manipulation, do you think that the bottleneck is hardware or software at this time? Is it about understanding the scene, the dynamics, like the structure, or is it just like making a motor that behaves like muscle? You know, is it hardware or software? Which one's the limiting factor?
That's a great question. And that's a debate within my research team as well, right? Is it the body or the brain? So I could say, at least from a bimanual coordination, right? I think we have landed on that hypothesis, saying I think it's more of a brain function rather than a hardware. And I think John and I were just chatting last night about soft robotics, right? Is that the intersection between the rigid mechanical structures we have today, and why are the VLAs, vision language action models, so brittle? Because are they translating that signal into a mechanical structure to interact with the object, or is it the soft body motion too? So our other thesis, I'll call it, is it's a hybrid, hard and soft structures for dexterous manipulation for sure. But at the same time, there is an AI and an automation stack that we just need to get clarified on. Not everything needs RL or machine learning or computer vision, right? Some of it, you could actually hard code it and just do it. And it's working pretty well. But when we're actually integrating multi-signals into a cortex, does that need a classification as well? So I think the answer is it's both. I don't know which way the balance is, but it's a brain and the body. Yeah. Yeah, definitely long term. So I think over time, it's not just the needle and the thread problem, it's how do you generalize across different tasks, right? So that generalization is the brain problem. Yeah, like I said, it's a hybrid. Yes, there is a body problem too of holding it, but how can I thread a needle, also transfer liquids between that same morphology as well, right? Is what we were referring to. Yeah. Yep.
Thank you.
Yeah, thank you.